for
Okay,
this.
cool.
Okay.
Okay, perfect. Let me just share my screen. All right, can you guys see this fine?
Yeah.
Okay, perfect.
Yes.
So yeah, this is the Comp 211 review session for the upcoming midterm. Like he said in the Canvas announcement, we'll be covering pointers, memory allocation, the GCC stuff, so compiling, assembly, and machine language, linking, reallocation, assembling, all that stuff, and then putting it all together at the end with header files. And we'll have a little bit of time at the end for questions, but since there's only two of you, I don't think that's going to take very long. But yeah, feel free to like write down any questions if you want in chat so we can have them for later. But yeah, Kevin, if you want to start, I'll just move through the slides.
Wait, come on second. You want to go first?
Yeah, actually, yeah, I can do that. So yeah, I might have to head out early, which is why I'll start first, just so you guys know. Um, so I'll start with the assemble, link, and load. So this step is basically to create a relocatable object file. The bytes are put into an executable and linkable format. We're going to call it elf. And every instruction in the assembly step gets an elf section and an address. And there are three different kinds of relocatable or object files that we look at. So relocatable, executable, and shared object. And we'll go through the steps of getting from one through the other. And typically we work with the executable object file, as you know, like the dot a slash out. Um, and yeah. The ELF section looks like this. And so you have the read-only sections, which is the dot text and dot row data. You have the data section and dot symtab, and then you have the dot rel text and dot rel data. And the last two is when you relocate info to these sections. And so from the beginning, the text section just contains machine instructions from your program. Uh, so like basic functions, things like that. The dot row data section contains read-only data like constants and global variables, or sorry, just constants. The dot data section contains the global and static variables. Dot sim tab contains the name and address of those functions and static variables and where they're located. And then the dot rel text and dot rel data um, will have the relocation info after the linker will relocates an unresolved data and addresses. And we'll go through this in a second, but if the linker can't unresolve or resolve those issues, then it stops or it breaks. Yeah, so like I said before, SymTab contains symbols in the program, functions, global variables, static variables, etc. And it contains the address to where those items are located. Data contains the byte size and data structure for every variable. And then the dot text section holds program instructions in 32-bit. Um, and then dot rel text and dot rel data, I should have put that in there as well. That adds an entry for every unresolved symbol from those previous sections. And then, yeah, Julian.
Yeah, hi. I was just wondering if printf would be in like the .rel .text section, like stuff like that, like in libraries, would that be in .rel .text?
Um, Kevin, if you know that, let me just double check.
Can you say your question again?
I was just wondering if like in .rel .text would stuff like printf be in there, like stuff in libraries?
Uh, yes, I think so. Yes.
Okay, thank you.
Yeah.
Kiara?
Yeah, so when we're talking about that row data, doesn't aren't string literals also included? And when they are, is does it count like if it's in a variable like a char array or like a pointer?
Say it again?
Um, Sorry, yeah, go ahead.
Um, so aren't string literals also counted in like the dot row data section? And when, if they are they included when they're like in like a char array or a pointer?
So they have to be placed in read-only data, like you said, because they're not modifiable. And they're, I think, put in an array format, not a pointer format, because it contains the value of
So
um
does it matter?
literal.
So
Yeah.
okay, cool. Thank you.
All right. Okay, yeah, so the linker step. Okay. So this is a step that's going to create an executable object file. It'll combine all the relocatable objects and shared object files and output an executable file that's called a.out. Um, and this is the step that does resolution and relocation, which creates the .rel files. And so symbol resolution is where the linker tries to find the value of any unknown symbols from one table and the other tables within the shared object files. And if this doesn't work in one resolution step, then it fails. And then relocation is conducted after resolution passes. And so it moves the .text and .data sections to an executable object file. Um, and the important part is that it's going to convert the relative addresses of all of the contents of the sections into final absolute misspelling, but into final absolute addresses in the executable object file. And this is just a like quick visual of what it looks like. This is from the slides. But P1O is one shared object file and SUMO is the other one. Not shared object, sorry, relocatable object file. And this is a step where it relocates everything that hopefully it's been resolved at this point. And so it's going to relocate everything to an executable object file. So it'll all show up in one massive file. And then this is what can be executed. And it's called fully linked at this point. And it should, yeah, so it's going to have the same memory addresses and stuff. Um, And yeah, you fill in the remaining sections with whatever other relocatable object files you have in there. And this is just an example of a .text section. So it just contains the addresses and then the instructions that are conducted within the assembly section of the program. And yeah, this is what it should look like. I mean, this is again with the slides that he gave you. So if you walk through that, it'll be really helpful. But this is what the .text section should look like after relocation is performed. And then comparing static to dynamic, well, I guess that's going to be a little bit ahead, but executable object files simply take up space. Um, they don't really do anything else on their own, so you have to run them. And in order to run them, this is a typo. You would do ./a.out. And A would be like whatever the name of your program is. It does not have to be A, so you can define it if you want to, but the default is A. And this will copy all the sections from your executable object file into the main memory and execute any of the .text instructions. And whenever a program runs, the OS will assign memory to stacked heap text and data, and the loader will copy all of the linked ELF sections to the correct main memory addresses. And then the libraries and header files, moving on a little bit. So your static library will contain multiple relocatable object files have been combined into a single file. And this will be called an archive, again with a .a extension. And some common libraries that you might end up using are libc.a or libm.a. And because it's static, you can use the archiver to allow incremental updates. So incremental updates would be the process of translating the program, updating the object file, and then updating the library symbol. So it's like a three-step process. Like you have to kind of essentially restart because it is static. And so static files, this is just like the command to see what the space is, what the space looks like on your computer. But since static files can be very large, you have to perform linking every time you want to fix bugs, and it's kind of a tricky process to step through. And for that reason, there is a thing called dynamic linking. Dynamic linking overcomes its limitations like space and time by using a shared library or the .so, and this is created with the GCC command. And so files within a shared library are given memory addresses. It can be shared between multiple programs. And the process for this is called dynamic linking. This occurs after the program is loaded into memory or during runtime, as opposed to just being copied into a library during static linking. And the linker does the same thing as before. It does the symbol resolution and relocation, again, terminates otherwise. And this essentially takes up less space. So if you went to his slides, you'd be able to see that previously I think it was taking like 80,000 bytes or something, and then with dynamic linking, it takes up a significantly less amount of space. And finally, header files. This is pretty standard. There's just a few things you need to know about this. Header files will include the function prototypes, constants, global variables. Again, you don't define functions in here. And you implement it or you define the functions in your .c or source file. And it's also in the relocatable object file and or the library. And it looks very similar to a Java interface in that you're just declaring everything. You're not actually like going through and defining anything. Um, and the syntax for this can look like hashtag include like studio.h with the not the brackets, but those symbols, or in quotations. And so the first set of symbols will tell the compiler to look for files in default directory. So this is typically if you did not define this file. And then the quotations will tell the compiler to look into a user-defined location. Sorry, this is if you define the location, not the file. And then this step is performed by the preprocessor. So any questions on the last chunk of the exam? Okay, I can go to the beginning now if you want to walk through that.
Okay.
Are you
So
guys gonna release these slides?
Oh yeah, I'll send them to our cohort. I'll double check with Brent that we can do that. Because I know that he has some restrictions about this kind of stuff, but I'll just double check with him that it's okay, and then I'll send it out.
Okay, thank you.
Yeah.
so I'm gonna share my screen, right?
Yeah, yeah, I can just
Okay.
stop.
No. Give me 1 second. All right, can I guys see my screen?
Yeah, yeah, we can
Okay.
see it.
Okay. So we're gonna talk about the pointers. Wait, how can I zoom this out? Like this. Okay. The first thing we want to know about the pointers is how to use pointers, and there is a syntax, right? And then there is how did you say I don't know how to say this symbol. That's the way how to use a pointer. And also, if you want to print out the address of that pointers, you're gonna use the P, not the dereference P. And then next thing is about the dereferencing, right? So what if I want to get the value that the pointers point to that address, right? So now we're gonna use the dereference like this. So it will showing up our 10 in this example. Pointers. And we can also by change the value like through the dereference of that pointers. Like for example, the I is 10 like before in here, but if we do the pointer dereference equal to 20, it will become the 20. And there is the another example about array and the pointers. So once you allocate the pointer to an array, so the pointer will start from the very first element to like assign that index. Like as you can see in here, the last part, the printf the PDR plus one, which will move our the pointers headers move one forward and become the two. So the output will be the two. And there's an example I showing on here and how to do the pointers. And there's the all the summary like about the pointers and the array. You can just take a look. Okay. If you have any specific question on some of them, you can ask. Let me
So
give
if you're not dereferencing the pointer, then it just like it will return the value, which it will return its value, which is like the address of the memory,
wait,
right?
the which one?
So like and like when you don't dereference a pointer, so you just put like
The
just P
address.
and not the asterisk,
The
then
yeah
it would just give the address, right?
yeah the address of that pointer.
Okay, cool.
So if there's no question about this page, we're gonna move forward. Okay. Wait. So next topic is the memory allocation. So the memory allocation, we have the three different part, which is program stack, program heap, and read and write segment, and read-only data segment. So these two part are the color of them are different, like we mentioned about before, because the file gonna go into the different place in our RAM. Like when we change it to the .o file, it will go to the different part. Like this part is for the function. Once you call the function, like main, function one, function two, all of them are in this part. And the program heap is about the method you use the malloc, right? Once you use the malloc, all the memory allocation will be into this part, and I will talk about this too like later. So the stack memory. We have to understand like when will the stack memory be created, right? So whenever the function is called, the SF is created, and it will go into that place in our RAM. And when will it be destroyed? Like once the function is returned, like there is many methods, and you will say, okay, return something, right? Return the variable ABCD EFG, like something like that. After doing that, this part are destroyed and will be removed from the program stack. And also you need to understand like what variables are included in the read-only data segment and the read and write data segment. So for the read-only data segment, we have to know there's the constant global variables are in here, and there are some string literals in here. And for the read and the write data segment, we have to know that the global variables are in this part and the static variable are in this part as well. And when they are created and when they are destroyed is when your program is start. That get into that main, right? Get into that main. Like read the code from the very first line to the end of that line. The once we start that function. Okay, these two parts are created. Okay, you can see the question if you ask. Yeah.
Hello. I was just wondering if so when you have like the main function,
Hmm.
so that a stack would be in a stack fragment would show up in the stack, right?
Yes.
And then would that like the name of the function also be in like the read only data section, like just main? Because that's a machine instruction.
Wait, what do you mean? Can be confusing. Like,
Sorry. I was just wondering if like main would also be in the read only data section.
no. The main is the name of the function, and it
Hmm.
will only go to the program stack, which is this part, our
Okay,
the green part, right?
right. And so then like what constitutes